In the present video, we will discuss the line balancing numerical problem. Let's see the problem. The company needs to produce 400 boxes of blocks per 40-hour week to meet upcoming holiday demand. The process of making blocks can be broken down into 6 work elements. The precedence and time requirements for each element are as follows. So the following table represents the various work elements with precedence relation. Moreover, it is given the performance time of each element. Then we have to draw the precedence diagram for the production process, determine the minimum number of workstations, and calculate the balance efficiency. Let's see the solution. First, we have to observe the given data. So in the data, it is given the company needs to produce 400 boxes of blocks per 40-hour week to meet upcoming holiday demand. So here it is given the number of boxes to be produced is 400 units, and also given the total availability time. So total availability time is 40-hour week. So 40-hour week mean total available time per week equal to 40 hours. Moreover, it is given the process of making blocks can be broken down into 6 work elements. So here, number of work elements are the 6. First question is, draw the precedence diagram for the production process. So for this, observe the precedence relationship of each work elements. For the first, you have to observe the work element A. For the work element A, there is the no precedence relation. So it is the start independently. So first you have to represent the work element A like this. So next work element is the B. For this, precedence element is the A, which means after completion of the A, it will be start. So draw the element B like this. Next work element is the C. For this, precedence element is A. So after completion of the work element A, C will be start. So draw the work element C like this. Next element is the D. For element D, there is no precedent element, so it will be start independently. Then draw the work element D like this. Next element is the E. For work element E, precedence work elements are the C and D. So after completion of the C and D, work element E will be start. So we have to draw the work element E like this. So it represents the work element E will be start after completion of the C and D. And next work element is the F. So for the work element F, precedence work elements are the B and E. So after completion of the B and E, F will be start. So draw the work element F like this. So next we have to represent the performance time of each work element at the respected elements. So first we have to represent the performance time of the work element is A. So for the work element A, performance time is the 0.1. So represent the 0.1. So at the work element A. So next for the work element B, performance time is the 0.4. Next for the C, 0.5. Next for the D, 0.2. Next for the E, 0.6. Next for the F, performance time is the 0.4. So this is the first question. Draw the precedence diagram for the production process. Next we will solve the second question. Determine the minimum number of workstations. So this will be solved in the two steps. Step 1 is determine the required workstation cycle time using the following formula. We know that when the workstation cycle time capital C equal to production time divided by required output. So in the data it is given the number of units. So our number of boxes to be produced is 400 and total available time per week is 40 hours. So production time is 40 hours and number of units or number of boxes are the 400. Here in the data it is given the performance time of the all the work elements are in the minutes. So we have to convert 40 hours into the minutes, that is the 40 into 60 minutes divided by 400. Then it will come the 60 divided by 10 which is equal to the 0.6 minutes. So after determination of the workstation cycle time, so in the step 2 we have to determine the theoretical minimum number of workstations, that is NT. We know the formula, minimum number of workstation equal to the sum of task times divided by cycle time. So it is the summation of task time of individual task divided by cycle time. So here there are given the 6 work elements with respect to the performance time. So task time will become the summation of all the performance time of the all work element. Then so sum of the task times, that is the summation of capital T which is equal to the 0.1 plus 0.4 plus 0.5 plus 0.2 plus 0.6 plus 0.4 divided by cycle time. Cycle time is 0.6 minutes. So it will become the 2.2 divided by 0.6 which is equal to the 3.67. So this is we have to round up the number, that is nearly value is the 4. So number of workstations, so minimum number of workstations are the 4. So next we have to solve the third problem. Calculate the balance efficiency. So we know that when the evaluate the efficiency of the line balance by using the following formula, that is the efficiency equal to sum of task times divided by actual number of workstations into workstation cycle time. So previously we determined the cycle time capital C equal to the 0.6 minute and number of workstations NT, N suffix T is the 4. So then efficiency will become the sum of task times. So it is the 0.1 plus 0.4 plus 0.5 plus 0.2 plus 0.6 plus 0.4 divided by, so NT number of workstations are the 4 into cycle time, workstation cycle time capital C is the 0.6. Then efficiency will become the 2.2 divided by 2.4 which is equal to the 0.9167. So this is the solution and thank you.